All right, second video to the section 3.5 operation of functions, dealing with the composite functions. The previous video we did composite functions. All right, let me review that. F of g of x equals f of g of x. That's the basic definition. And we did it with number inputs, where we just actually had an actual value for x, and we've got actual value as our answer. Right. Now we're going to leave it just the way it is. In other words, we're not going to put any number values. We're actually going to put in a whole function. We're substituting functions within functions. All right. So now we're on a higher dosage of steroids. Okay. So let's define two functions. All right. We'll go back to the ones that we used in the previous video. Okay. And now since we're actually going to have a new function, we're actually going to have to find the domain of it as well. All right, so...
Security, please stop down in the principal's office.
Okay. So we're going to take the function of g and we're plugging it into f. All right, so in other words, keep f. All of g right here means we're going to f. All right, so let's look at it this way. I took g of x out because g of x is equal to this, so I just replaced it. So what that means in the function of f, so first of all, I'm going to take the function of f, I'm going to rewrite it, put parentheses where the x was. All right, so that still has the exact same form as the function of f. But what was going to make it different now is that I'm plugging in this, what used to be x, now it's going to be all of this. And that's what I get. You guys are probably freaking out right now. Well, eventually you'll get it. It's not as hard as you think it is. All right, it's just a new concept and something that we'll just have to work through. All right, so now I'm going ahead and just simplify this. All right, so if I would square this, this becomes 1 over the quantity x plus 2 squared plus 1, and then multiply, so I get 4 over x plus 2 quantity squared plus 1. And you can leave it like that. Okay? You don't need to multiply this out because I like the denominators to be factored anyways. Now we're going to find the domain. Now you look here, I have a denominator with a variable on it, so that means I have a restriction. We know the denominators, in this case x plus 2 quantity squared, this whole denominator cannot equal to 0. All right? So I'm just going to solve it just like normal. So I take the square root, x plus 2 quantity squared still does not equal to 0. We got rid of the square, sorry. Now I'm going to subtract 2. So x does not equal to negative 2. So that means if I put negative 2 in here, negative 2 plus 2 is 0, 0 squared is 0, I can't have that. So that's the reason why it cannot equal to that. So my domain, x cannot equal to negative 2. To write that in interval notation, we will say parenthesis negative infinity to negative 2 parenthesis, then parenthesis negative 2 to positive infinity. All right, that is composition functions where we're using generic inputs. In other words, we're using whole functions and getting a new function. All right, so let's do one more. Let's define them. F of x is equal to 5x squared. G of x is equal to the square root of x. Again, I can go, order is important here, so let's see, let's just keep it as f of g of x. Okay. So first thing I do, I take g of x, I replace it. G of x is what? Square root of x, so I just put that there. This tells me in the function of f here, I'm going to take this, rewrite it without the x. See how it still has 5 times something squared? It still has the same format, but now I'm going to take this and I'm going to plug it into here. Right, and now I just simplify it. So when I square that, I just get x, so 5 times x is 5x. So there's my new function. The domain is all reals, because there's no fractions or radicals. And an interval notation would be parenthesis, negative infinity to positive infinity, parenthesis.